This is part 2 of our midterm review question solutions. Question 8 gives us data about commute times from students randomly selected. We hope it should say that at LMC. So here's our data, and we want to create a stem plot. Since the values range from 8 to 64, I put the stem at the tens place and the leaf at the ones place. The lowest value is 8, so I need to start with a 0 in the stem. And then I go in order from 0 up to 6 for my stems. So this represents the 10s, 20s, 30s, 40s, 50s, and 60s. Even though there are no values in the 50s, you have to make sure and include the 5 in the stem so that we can see how the data is spread out. So looking at this, the peak seems to be in the 20s, and if we rotate our heads, it looks like this has a little bit of a right tail. If you took out the outlier, you could probably argue it's roughly symmetric. So we're going to go ahead and find the 5-number summary. So we could start by finding the median in the middle. Since there's 20 commute times, we have an even number, so we're going to have to add and divide the two middle numbers, find the average of the middle. So if you count out between the 10th and 11th places, whether you start at the low end or the high end, when you count, you should end up between 23 and 25. I know my scan's a little hard to read. You can see I put a little line in here between the 3 and the 5 and the 20s row. So to find the median, we average 23 and 25, and we get 24 minutes. Now we want to find the first quartile. So the bottom 10 numbers, the halfway point is going to be between the 5th and the 6th number. So I am going to count out from the low end and find where's the 5th and 6th values. Again, we have an even data set, so that's going to be between 18 and 19. So I add up 18 and 19, divide by 2 to get 18.5 minutes as my first quartile. Quartile 3 is going to be between the 15th and 16th values. So I could start at the median or start at the max and count to find between 5 and 6 there, which would be between the 15th and 16th values. So that is between 34 and 35. So we add those up and divide by 2 to get our third quartile is 34.5 minutes. And then the minimum is 8 and the max is 64. So we've got our 5-number summary there. Now we want to describe the distribution in terms of shape, center, and range. So the shape, we say it's got a right tail. You could say, if you took out the outlier, it might be roughly symmetric. The center, we could describe that in two ways. We could describe it as a median, 24 minutes. You can also find the mean. So to find the mean, you would add up all the values and divide by 20, or since you're able to use StatCrunch, go ahead and put that list in StatCrunch and have StatCrunch do the work for you. So in StatCrunch, you go to Stat, Summary, Stats, and ask for the mean. Then the range is from 8 to 64 minutes. So if we subtract 64 minus 8, we see our range is 56 minutes for these commute times. Question 9 is a two-way table from textbook chapter 2. I think that's in the old edition. In our current edition, this was covered in chapter 3. They changed chapter numbers recently. So the rows of the two-way table are measuring whether someone has health coverage or not. And then the columns are measuring someone's health status. And the ratings go from excellent to very good to fair to poor. And this came, we're told, from an annual telephone survey. So this is real data from the Behavioral Risk Factor Surveillance System. And we are going to investigate and do some probability calculations. So question A asks, are being in excellent health and having health coverage mutually exclusive? So if we look at the table, there are people who have health coverage, yes, who are in excellent health. So we would say this is not mutually exclusive since there are survey respondents who have both excellent health status and health coverage. And that is the 0.2099 in the survey. Question B asks, what is the probability that a randomly chosen individual has excellent health? So that's a marginal probability. So we add up everybody in the excellent health status column, and that is 0.2329. I don't have to do any division here because this is a relative frequency table, so all the cells inside the table have already been divided by the total, so our total is 1. So you could write down 0.2329 divided by 1, but you would still get 0.2329. So it's one of the things I like about relative frequency tables is I don't have to do any division to find the probabilities. It's already done for us. Question C asks, what's the probability that a randomly chosen individual has excellent health given he has health coverage? So you can see that I underlined the given condition because this is a conditional probability. So the way I wrote this in part C is the probability of excellent health, and then I restricted this to yes, they have health coverage. So the total with health coverage is 0.8738, so that's the value we put in our denominator. And then restricted just to that row, those who are reporting excellent health are 0.2099. So when we divide, we get 0.2402. Then question D asks, well, what's the probability that a randomly chosen individual has excellent health given that he doesn't have health coverage? So this is another conditional calculation where we do the probability that someone has excellent health given that they have no health coverage. So our denominator is going to be the part of those in the survey with no health coverage, the 0.1262. And our numerator then, we're just restricting ourselves to that row, and we're counting the part who have excellent health. So that is 0.0230. To be able to compare it to my other conditional probability, because the groups are different size, I need to follow up with that division, and I get 0.18, looks like 0.1823. So that does look like a difference. So I'm starting to wonder if there is a relationship or an association between having excellent health and health coverage. So question E asks just that, do having excellent health and having health coverage appear to be independent or not? So we have to compare the marginal and conditional probabilities. So luckily we've done all these calculations in parts B, C, and D. So I'm going to check the probability somebody has excellent health given, yes, they have health coverage, and divide that by the probability they have excellent health. And so when I do that, those values are actually pretty close, the 0.2402 and the 0.2329. So that's 1.0313. So that's within our 0.95 to 1.05 range. So I might think that everything's okay there. But then I also need to check the probability that somebody has excellent health given that they do not have health coverage and divide that by the marginal probability. And when we do that, we see that there is an association because this is not close to 1. We get, when we divide 0.1823 divided by 0.2329, that conditional probability divided by the marginal probability, we get 0.7827. So it's far from 1. It's not in the 0.95 to 1.05 range. So you need to make sure that you're checking both conditional probabilities if you get one that seems like it's close to 1. If you get a conditional divided by a marginal that's far from 1, then you can just stop, because as long as you see one instance where it's far from 1, you know you're in not independent relationship territory. So we can say this is not independent. There is a relationship between health coverage and excellent health. So it got cut off a little, but that's all it's saying is that there is a relationship. Question 10 tells us about an exam Sophia took for a medical program where there were 2 sections, verbal reasoning and quantitative reasoning. You might hear of people taking the MCAT or other tests for trying to get into different programs. So on the verbal reasoning section, Sophia scored 160 points. And on the quantitative reasoning section, Sophia scored 157 points. The mean for the verbal reasoning section for all the test takers was 151 with a standard deviation of 7. And the mean for the quantitative reasoning section for all the test takers was 153 with a standard deviation of 7.67. So we are going to find Sophia's z-score on the verbal reasoning section. So we calculate z equals 160, Sophia's score minus 151, that's the mean from the verbal reasoning. And then we're going to divide by 7. So 9 divided by 7 is 1.2857 after we round. And then we do a similar calculation for the quantitative reasoning. We do 157, Sophia's score, minus 153, that's the mean, and divide by 7.67, so that's 4 divided by 7.67, and that's 0.5215. On both of these sections, Sophia did better than the mean because she has positive z-score, so that's a good result for a test where you want to score higher. Question B asks, which section did Sophia do better on relative to the other test takers? So we can see Sophia scored higher above the mean on the verbal reasoning section since that's got a higher z-score. That means she's more standard deviations above the mean. And then we want to circle the StatCrunch screenshot that shows a proportion of test takers who did better than Sophia on the verbal reasoning section. So it's hard to see here, but you could check on your PDF that you have of the original practice questions. So the last choice here is the best. It's the match because you could see that we are comparing to Sophia's score on the verbal section, the 160 is in here, and then we're looking at the people who scored higher than that. So we want to know those who did better than Sophia. And then we want to know, did Sophia score unusually high compared to the other test takers? So Sophia scored 1.2857 standard deviations above the verbal reasoning mean, which is not unusual since it is within 2 standard deviations. Sophia scored 0.5215 standard deviations above the quantitative reasoning mean, which is also not unusual. So if Sophia had been more than 2 standard deviations away, that's when we would say she did unusually well, or if she was on the low side, we'd say she did unusually low. Question 11 tells us about a study that researchers from Switzerland and New Zealand conducted to see if vaping users were able to stop smoking. You can read the results here from the Journal of Addictive Behavior in 2014. You can see the sample sizes were pretty large. N equals 477 for the group after 1 month, and N equals 367 people for the group after 1 year. So reading through, we want to identify the explanatory and response variables. Notice that I underlined the research question. They were trying to see if vaping users were able to stop smoking. So I said the explanatory variable here is whether the person is vaping or doing e-cigarette use. And then the response variable is whether they were able to stop smoking or not, because we think the vaping or e-cigarettes are what explain whether or not people are able to quit smoking per this study. So we want to know if this is an experiment or observational study. So when you read through, you'll, I think, agree with me that this is an observational study. Since participants were not manipulated, participants were randomly selected from existing e-cigarette users. And then we're asked to think about what are some possible confounding variables influencing the study. So we have diet, exercise, family history, age, etc. So you could have an infinite number of possibilities that you list here. So give at least 2 or 3 possible confounding factors for a question like this. Question 12 gives us the 5-number summary for a group of 100 runners in a 5-kilometer race. So the variable we're measuring here is the amount of time in minutes it took someone to complete the race. So here's our 5-number summary. It goes from 15 to 50 minutes. And then we want to decide what is the most accurate statement here. So statement A says most people finished between 15 and 50 minutes, but some people took a little longer. Well, that's not true because the maximum is 50 minutes. So nobody took longer than 50 minutes. Question B says there were more runners in the second quartile than in the third quartile. Well, that's not true because every quartile holds 25% of the runners. In this case, there were 100 runners, so that makes our math easy. There were 25 runners in each quartile. And then C says at least 25 runners had times ranging from 31 minutes to 32 minutes. And that's true because our median to quartile 3 contains 25% of the data. They said at least 25 runners because it could be we had a whole bunch of people that were 31 minutes. And so the median could be one of those 31 minutes. So it could be there were some times below the median that were also 31 minutes if many people had that running time. All right, question 13 has us looking at 2 box plots comparing cardiovascular disease, CVD, rates as a percentage of total deaths for 155 countries. And then we're looking at the per capita supply of vegetable protein over here on the left side. So we've got high or low. And we want to know which of the following statements is not a valid conclusion that could be drawn from the box plots. So statement A says the medians are close. This suggests that the typical CVD mortality rate is about the same for both groups of countries. So that seems reasonable. So I would say, yep, that seems valid. It looks like both of the country groups have a median of 30 mortality rate. And we're just comparing countries that have high or low vegetable protein, I think, in their eating habits. B says if we use quartile 1 and quartile 3 to define a typical range of values, the countries with a high per capita supply of vegetable protein, so it's the top graph, have a typical range of CVD mortality rates between 31 and 47.5. So that's the one I say is invalid, because just looking at the central box from quartile 1 to quartile 3 for the high protein range here, high vegetable protein range here, that looks like quartile 1 is somewhere between 10 and 20, and it could be quartile 3 is 47.5, but quartile 1 is definitely not 31. All right, question C would be valid then. If we use range as a measure of variability, then the group of countries with a low per capita supply of vegetable protein has more variability, and we would agree with that because it looks like its distance from min to max is a bit longer for the low vegetable protein countries. And then question D says if we use the interquartile range as a measure of variability, then the group of countries with low per capita supply of vegetable protein has less variability. And that makes sense because the central box for the low vegetable protein countries is smaller than for the high vegetable protein countries. Question 14 gives us a histogram, and it's got the labels on top for the counts for the height of each bar. And then it asks us to pick the box plots which one of these box plots that matches the histogram. So we have to count out where the quartiles are. So there's 123 countries. So you could do 123 divided by 4 and figure out quartile 1 must contain the 31st person. So if you add up until we get to 31, a 1 plus a 12 is not quite there, so then we add 26. So then we're in that 12 to 18% column. So quartile 1 is got to be in the 12 to 18% column. The median must contain the 62nd person. So if we add up and get to the 62nd person, we see the median must be in the 18 to 24%. And this is counting the daily tobacco smokers as a percent of the population. And then similarly, we figure, okay, if we take those 123 countries and figure out where it's 3/4 of the way through, or you could times it by 0.75 or times it by 3 out of 4, we figure the 92nd person is the third quartile. You could also just count 123 minus 31. That would get you there also. So if we add up all 92, so we're adding up all of the column heights, so we get to 92. We end up over here between 24 to 34% column. So adding up 1 plus 12 plus 26 plus 27 plus 31 gets us to 92. So using that information and trying to match what we see here in the graphs, it looks like box plot C is the one that has quartile 1 between 12 to 18, the median between 18 to 24, and the third quartile between 24 to 30. Question 15 tells us about a local swim club, and they have some races that are open competitions with no qualifying times, and other races are qualified competitions. So we are thinking about the groups of 15 to 16-year-old females who swim the 100-meter freestyle in the open competitions, and the 15 to 16-year-old females who swim the 100-meter freestyle in the qualified competitions. So we want to know which group's distribution of race times would most likely have the largest standard deviation. And so we say answer choice A here. The group competing in the open competitions is most likely to have a higher standard deviation than the group competing in the qualified competitions. And my reasoning here is that open competitions will have a wider range of freestyle times since anyone can compete. If you think about a group of qualified competitions where students had to get certain times in order to compete, it's going to be narrower because you're not going to have the slower swimmers like me who would be outliers. All right, remember to also look through our class notes and your group quizzes or group exam. and any comments you have from me in preparing to study for the midterm.